Good afternoon. Welcome back to the states of matter and gaseous states. Yesterday we have seen the intermolecular forces, van der Waals for attractions, and in that subcategories and hydrogen bonding and all. Then finally the most important Boyle's law also we have seen. That is PV equal to constant at a constant temperature and mass. That is P1 V1 equal to P2 V2, or whatever the way you want to express, that is the most important. Today we will see the Charles law. Charles law. Yesterday we have seen the isotherms also. Charles law, this is another important. Actually it has started with the air-bent technology, means how the gases will expand with volume is expanding with the temperature and all. That means it is a volume temperature relation. Earlier one is pressure volume relation. This is a volume temperature relation. Once we are relating to two, the other two will be constant. That means when we are talking about V and T, the constant is P and mass. Earlier one is when we are talking about P and V, constants are T and N, right? So how it will be varying volume and temperature? After so many experiments, Charles has proposed this thing. For every 1 degree centigrade raise, there will be a raise in initial volume by 172, 1 by 273.15 times. That means if initial volume is V0, then for each 1 degree, there will be a raise of 1 by 273.15 V0 times. That means if Vt is the final volume, then initial volume is V0 plus V0 into 1 by 273, 1 by 273 point for 1 degree. If it is a T degrees, T by this thing. This much is this thing. Finally, once if you write this Vt equal to V0 and this 273 plus T you consider as 273.15 plus T by 273, that is nothing but newly proposed temperature is, that means it is not 0 degree centigrade all the time. Now we have to have a new temperature scale, that is minus 273 degree Kelvin is the absolute zero. It was decided. That is called thermodynamic scale or thermodynamic absolute temperatures. At that temperature, no gas will be available. So, okay. Now, if you see this one is T1 you take Vt equal to V0 T capital small by T0, then that is implies V2 by V1 equal to T2 by reverse T2 by T1. That means V by T equal to constant at constant pressure and mass. This is the Charles. This can be, that means V is directly proportional to T. If you see the constant, this V is directly proportional to T. That is the Charles law. Now, if we are making a small graph in this, here it is the volume and the temperature in the x-axis. It not starts from 0, it starts from the 0 degree centigrade and minus 273 R plus 273 Kelvin. That means absolute 0. This is minus 2 from 0. So here the gases are the dotted lines. Dotted lines are nothing but the where it is going. Actually the solid liquefying and solidifying, it doesn't exist as below this temperature. So there are so many slopes. So fine at constant different pressures, P4 or P3, P2, P1. This is the temperature. Now if you see, that means it is called isobars. Earlier one is isothermal. temperatures are constant. That is iso temperatures. Fine. Isotherms it will be called. Here it is isobars. Now, okay. Then this is the Charles law. V is proportional to T. Then other one is my initial one is P is inversely proportional to V. That is Boyle's. Okay. After third law. What is third law? It is Gay-Lussac. Gay-Lussac. What is given? Now PV is over, V and TV is over. Now P and T we will see. See, all the three one by one we will see. This is P and T. The P is directly proportional to, here VT is proportional to T, here P is also, because here both are inverse, so here P also proportional to T. That is Gay-Lussac. At same, at constant volume, and the other two always you have to remember, very simple. Whatever you are considering two, other two, that are four, other two should be constant. Here P and V, the temperature and the mass is constant. Here P and T, volume and mass is constant. This is Gay-Lussac. Now the fourth law also is there. Fourth law is also there. Before going for the ideal gas, fourth law is Avogadro. Avogadro law. What is this law? That is mass and volume. Now so far we have not touched the N. Now first time we are touching the N and volume. So V is proportional to N at constant P and T. That means equal volumes of all the gases under the same conditions of pressure and temperature. When the volumes of the two gases are equal, or any number of gases, their number of moles equal to same. In the each mole you will have the same Avogadro number of the molecules. That is 6.023 into 10 to the power 023 into 10 to the power 23 molecules will be there in the, that we have seen as a mole and all these things. So this is the in relation between V and N. Similarly, here also we can make some graphs. So these are the total four laws. One is the Boyle's law, second is the Charles law, third one is Gay-Lussac's law, fourth one is the Avogadro's law. After this, we can go for the ideal gas equation. So how the N is related? N equal to mass by molar mass. N is the number of moles. Mass by molar mass equal to number of moles. So V is proportional to N or constant. These are the four laws one has to remember for the exam point of view and all. Just simple this thing. Now before going to the ideal gas equation and all, we'll just two problems we'll solve. Simple problems, very simple, but the slight small confusion. A small confusion is there in this thing. What will be the minimum pressure required to compress 500 dm cube? Here it is only small confusion. Dm cube of air at 1 bar. This is also small confusion. 2, it is compressed to 200 meter cube, 200 dm cube at 30 degrees centigrade. Here unnecessary things are many, so confusions are many. So volume is given as a 500 dm cube. Normally we have seen so far the liters and all these things, and pressure is given bar, and he is asking the pressure. A simple equation actually P1 V1 equal to P2 V2. Very simple, half minute or less than half minute calculation only. But immediately people will say what is the dm cube, what is the bar and all. Don't worry about all those things. Dm cube only. But if you want for the academic purpose, dm cube is nothing but liter, decimeter cube. Decimeter cube equal to 1 liter. That is actually for academic interest. But if you see what is given 1 atm, first pressure is 1 bar, and V1 is equal to 500, equal to P2 is to be found out, and V2 equal to 200 dm cube. So 500 by 200 equal to 2.5 P2, that means bar. It's a very simple half minute job, but the confusions are dm cube and bar. One more problem we will see. that is a vessel of 120 ml vessel is taken. 120 ml, here also confusion. 120 ml of vessel is taken, capacity of vessel taken, and the gas is at 35 degrees centigrade and pressure is at 1.2 bar. The gas is transferred to another vessel. This vessel is vessel capacity is 120 ml at 35 degrees centigrade, 1.2 bar. Now another vessel is taken. That vessel capacity is 180 ml. Okay. Now that is also at 35 degrees centigrade. So confusion is vessel volume is giving. Vessel volume is nothing but the gas volume. For the gas, there is no fixed volume. Whatever the vessel is there, that is the volume is the same. So now what he is asking, again same thing, he is asking what will be the pressure? What will be the pressure in the bars? So 120 into, first initially is 1.2, temperature is same, so we need not to worry. Then another volume is 180 ml, then he wants the P2. So here it is 260 is 360 is so equal to P2 equal to 1.2 into 2 by 3 is a 0.4, nothing but 0.8 bar. Very simple, is a less than half minute bar. Only thing is the vessel volume, this small confusions. Thank you. Tomorrow we'll see the ideal equation and the ideal gas equation and other things.